day 12 now in Algebra 2. And for your do now today, I gave you this worksheet where there are 20 different parabolas. Just kidding, 16, not 20. There's 16 different parabolas. And on the directions, it says that I wanted you to identify the vertex, the axis of symmetry, the direction of opening, the y-intercept, and the x-intercepts, or the zeros. So let's start by looking at number 1. And I'm going to do it, I guess, just in the order that it has it in the direction. So below this, I'm going to write, well, I guess we could just label the graph. Okay, first, vertex. Does anybody know where's the vertex for this first graph? Go ahead, Julissa.
I want to say it's at -3, 2. Yeah. -2.
-2 would be right here.
Okay, so it's.
Thank you. So it's, let's see, the vertex, remember, is that point right here, right? So I want to see first, where does it line up with the x-axis?
-5.
Yes, -5. So that's going to be my x value, -5. And then where does it line up with the y-axis?
-2.
Almost. There's -2.
1.
-1. Good. I know these graphs are a little tricky because they label every other number.
Yeah.
So you got to kind of look between the numbers. On a quiz, I'll have all your numbers labeled. Okay, so that is our vertex, -5, -1. So next, we want to know, what is the axis of symmetry? The axis of symmetry is always going to be related to the vertex, -5. It will have the same x value as the vertex. And your axis of symmetry has already been drawn in here. So it's that line where both sides are equal going through the vertex. And it is x equals same x as the vertex, -5. So down here I'll write axis x equals -5. Okay. Up next, I want to know the direction of opening. Is it up or down? It's up. So direction up. Now we're looking for the y-intercept. Where do we touch the y-axis?
-5.
Yes, +5. Right here, my line goes right in between 4 and 6. I would say this is about 5. So my y-intercept is 5. If I wanted to write this as a coordinate, what would that coordinate be? 0, 5. Good. Good. Okay, and then last but not least, let's identify our x-intercepts. So where do we touch the x-axis?
-7, -3.
Yes, -7 right here, and between -6 and -8. That's 1. And -3, right in between -2 and -4. So I'll write over here x-intercepts. We can either say x equals -7, -3. What's one other way I could write these?
With the squigglies.
With the squigglies, the brackets. We could say -7, -3. Can I use parentheses?
No.
No, unless I'm writing 2 coordinates, right? So could I write these as coordinates if I really wanted to? I could. How would I do that? Like, what would my -7 coordinate be?
7, 0, -7.
Yeah, -7 in the x spot, 0 in the y. And then what would my -3 be?
-3, 0.
Perfect, -3, 0. So there's 3 different ways you could write your x-intercept. You don't have to write all 3. As long as you know one of them, I will accept any of these 3 options. For your y-intercept, you've got 2 options. You could say that coordinate, or you could say y equals 5. Good. I guess since it is a single value, you could also put the 5 in brackets. You could do that too if you want. We have options. Okay. Any questions on number 1? All right, I'll leave that up for just a moment. Let people copy things down. And here in just a minute, we will look at number 2. Can I move my paper? We ready for 2?
One minute.
Okay, take your time. You're fine. Just don't want to move it too fast. I'll pause it. All right, let's go ahead and look at number 2. So first, what is my vertex?
-2, -1.
Yes, right here, that's my vertex. It lines up with -2 on the x-axis, -1 on the y-axis. That's my vertex. What about my axis of symmetry? -2. X equals -2. Same x value as the vertex. X equals -2. And that is our dotted line right here. Hey, what direction is this one opening?
Down.
Down. Good. Down. And now let's look at our intercept. Where is the y-intercept?
I have -4.
-4. Good. That's exactly right. -4 is our y-intercept. So I can write -4. I could write y equals -4. Or what would my coordinate be?
0, -4.
Yes, 0, -4. Now, the trickiest part of this one, where are my x-intercepts? There are none. This is a special case where we don't have x-intercepts. So if there's no intercepts on the x-axis, we can just write none. It does not cross the x-axis. This would be a problem where if we tried to solve it with the quadratic formula, it wouldn't work. We would get no x values because there are none. It does not cross the x-axis.
Okay, I have a question.
Yes.
So if we put 0, would that be wrong because 0's in the middle?
That's a great question.
If I
That
put 0.
that would be wrong. Now that's okay because we've never done one like this. 0 would mean that it's right here. But since it is not right there, if you had 0, that wouldn't be correct. It would be correct though if you put a slash through it. That means none. So if you put 0, just put a slash through it and then you got it right. Okay, so that is number 2. Yes.
Would it ever be a problem when you have to solve because there's no
Yeah, sure.
x-intercept?
There could be, but I won't give you one on our quiz. I won't give you one like that. I won't give you one. Not one where you have to solve for x anyway. I might give you one where you have to find the discriminant, which we'll talk more about that today, but not like this.
You said this was a special case problem?
Yes, this is a special case because it doesn't touch the x-axis.
Gotcha.
So there's no x-intercepts. Okay. Can I move to number 3? Does anyone need more time?
Yeah.
Okay, you're fine. I will pause. You guys just let me know when you're ready. So that was number 2. Now we're going to look at number 3, and then we will go all the way to number 4. That's all we're going to review for our do now, unless there's other problems that any of you just want to see. We can absolutely go through some more. So let's look at number 3. Get my camera straight on it. And now, ooh, I gave you a tricky one on accident a couple times. Let's see. So first, let's identify the vertex. Where is my vertex?
3, -1.
Good. 3 on the x, -1 on the y. That's our vertex. So 3, -1. How about our axis of symmetry?
3.
X equals 3. Same as the vertex. X equals 3. And we can see that dotted line goes through 3 on the x-axis. Okay. Next, what direction does this one open?
Down.
Down. Good. Now, y-intercept. Now, this one is tricky because you can't see the y-intercept. They gave you a graph where you can't see it. So that is going to be difficult to do just by sight. Yes. Were you going to say something? Ooh, that's a good idea. That's a good idea. I will tell you this, an intercept is always a single point or multiple single points. So it will never be infinity, but I like the way you're thinking. It won't be infinity. This one is, I don't like this one because it should have a line where you can see that it goes through. I'm going to have you guys extend this. I will never give you one like this on a quiz, okay? I'll always give you obvious answers. If this graph were extended, it would go through around -9.
Okay, I have a question.
Yes.
So will it always be a y-intercept?
Yes, there will always be a y-intercept because that graph or that parabola, because the arrows mean that it goes on forever, it is forever infinity in both directions going to be going farther and farther, and it eventually will touch the y-axis at some point. Now, this one is, again, funky because you can't see it.
And is that because it's going outside?
Yes, because it's going outside of the graph.
Yeah.
If this was a better problem, they would have moved this axis up and moved the whole problem so you could see the whole thing. I didn't realize this would give you problems like this whenever we did it. So we're going to give an estimate. We're going to say y-intercept. And it looks like it would have crossed around, it could have even been -10, -9 or -10. There is an algebraic way that we can solve for the y-intercept. But for the purpose of what we're doing, I just want you to be able to see it on the graph. You can't see it, so we're going to guess. All right, guess.
Yeah.
And we will say that it is -9.
Okay.
That's our guess. And what would the coordinate be?
0, -9.
0, -9. Good. Number 4, whenever we get there, it does the same thing for the y-intercept. They don't give it to you. Now, how about x-intercepts? There are none. Again, this will never touch the x-axis because it starts below and it's extending forever downward. So it can never go back up and touch the x-axis. So there are none. This is another special case.
So it's always gotta meet in the middle for it to be the zero, the location of the zero.
The location of the zeros, it has to cross that x-axis for there to be zeros. Because the x-axis is here, and the starting point of my graph is already below that, it will never touch that red line ever. Because it's only going to keep going lower.
Right.
So there's no x-intercepts here, no zeros. Okay.
So, one more question.
Yeah.
You're saying that the, location of the zeros and the x-intercept kind of go together?
Yes, yes. The x-intercepts are the zeros. They're the same thing. So if I'll look at number 1 because there actually are intercepts. If I wanted to ask you, what is the location of my zeros? I could say -7 and -3 because that's where the x-intercepts are. So maybe we can make a note that these are also called the zeros. It's the same thing as an x-intercept. Do you guys know why those are called the zeros? Maybe I won't
Because
leave.
it's like a starting point of trying to figure out,
I see where you're going. I'm going to give you this reason. So the reason is that, so why are x-intercepts called zeros? X-intercepts equal zeros because when I have a quadratic equation here, and in this equation we have, this is not written in a form that you're used to. This is y equals 1/4 times x plus 5 squared minus 1. Whenever I put 0 for y, when y is 0, x is equal to -7 and -3. So let me prove that to you. I'm going to write this equation and show you. It's y equals 1/4 x plus 5 squared minus 1. Okay. So we said that the zeros of this equation are -7 and -3. That means if I put, for example, -7 and replace it with my x, when I plug in this -7, my answer is going to equal 0. So watch this. 1/4 times -7 plus 5 squared minus 1 equals y. And when I solve for y, I should get 0. So real quick, if this is my problem, we want to think about the order of operations. What could I do first?
what's in your parentheses?
Parentheses. So I have -7 plus 5 in parentheses. What will that give me?
-2.
-2. So -2. I'll bring everything down. What else do I need to bring down?
You still need to square it.
I still need squared. What else?
-1.
-1. What else?
1/4
1/4.
equal y.
And then the y equals. Good.
You gotta do another problem.
Okay, so now we're using the order of operations still. We just did parentheses. What's the next step?
-2 times.
-2.
Yeah, next is exponents. So I'm going to do -2 squared or -2 times -2. What does that give me?
-22.
That
Oh,
would
you're
be
doing
-2 times 11. -2
Two.
times -2.
+4.
Positive
Okay.
4.
-2 times. Okay.
Okay, so I got +4. What comes down?
Your y equals 1/4. -1.
Good. Y equals 1/4 times 4 minus 1. Okay. Now I have this. I don't have any more exponents. So what's the next step in the order of operations?
So now, yeah.
Multiplication and division. Yes. Okay. So I have 1/4 times 4. This is also like 1 divided by 4 times 4. That's all a fraction is a division problem. So if I type this in, 1 divided by 4 times 4, I get 1. Right?
Yes.
So I'm going to cross that out, and now I have 1. I'll bring down -1. I'll bring down y equals. And what's 1 minus 1? Y equals 0. So that's why our x-intercepts are called zeros, because when we plug them in, our y equals 0, which is kind of cool. Okay, let me freeze this. I'm getting it. All right. So interesting. Very interesting. That's not something I'm going to ask you to do on a quiz. This is just a little bit of background to explain why it's called a 0.
What part was that for?
That was for number 1.
Well, that's 5 steps.
Yeah. Yeah, there we go.
Wow.
Okay. And did you still have a question, Kate?
Wow, I was like, can't you just put like when you solve 1/4 times 4, fill out -4?
Put one other. Yes,
Just
you
fill that.
totally could. And it would be like 4/4,
Yeah.
which is 1. You definitely could. Okay. See, some of us writing that down, so I'll give us another minute before we get started. All right, so now let's go back to, we just did number 3. And that was the last part of number 3. We found the x-intercepts of the zeros. There were none. So now let's move to number 4. This will be the last one that we go over together, unless, of course, you guys have any questions about one later on in the worksheet. I'm happy to go through those or give you guys an answer key if you want to just double check your work. So for number 4, we're going to start the same way. What is my vertex?
-5/4.
-5, 4. Good. Lines up with -5 on the x-axis and +4 on the y. So vertex is -5, 4. Okay. Now, how about our axis of symmetry? -5. Good. X equals -5.
The same.
Yes, always going to be the same as the X on your vertex.
Same color.
Mm-hmm.
They're almost the same.
That's right. These will always, always, always be the same. That's a really good thing to have in your notes. Okay. Next, let's see. The next thing we look at is the direction. Is this one going up or down?
Down.
Down. Direction down. Now we're gonna look at the intercepts. Where, well, y-intercept would be the next thing, but you can't really see it. Can somebody give me their best guess where this might end up landing? Maybe -10. Could be lower than that, could be higher. Let's see. I'm gonna draw this line a little further down and see what it looks like. Again, I will not have you do something like this on a quiz because that's just not fair. I think with that,
-9.
Hard to tell what would happen because it almost looks like it would go really far down. See.
Almost like 13.
Yeah. So there's not a great guess here. So for this one, you could, if this was like a problem that I gave you, which it won't be, but if it was, you could say not visible. I can't see it. But if we made a guess, let's see. You said maybe 13, -13.
Well, I counted and it said -14, -15.
Okay, so we're gonna guess -14, just for fun.
-14?
Yeah, we'll say y equals approximately -14-ish. We're guessing though. And then last but not least, let's identify x-intercepts. We finally have some.
-30.
Good. -7, -3. So x equals -7, comma, -3. Or I could do brackets. Or I could write coordinates, of course, too. Okay. How do we feel about parabolas? Is it feeling a little easier? Good. Good. It's one of those things that looks like a lot, but once you practice it enough, it's not too scary. If you got good notes, you'll be able to reference those notes, and it will make your life a lot easier. So, all right. I'll leave this up for just a minute in case anyone is copying things down. And before we move on, does anybody have any last questions about this, or are there any parabolas later on in the worksheet that you're dying to know the answer to?
Probably when we take the quiz on this or whatever.
Mhm.
Are you gonna have the bonus part in there where it's the maximum?
Yes, I will. Do you want to practice some of those?
Maybe once or twice.
Okay, let's do that. So
right here.
yes, like the max and the min.
Okay.
So let's talk about that. The bonus. I'll do this on a sticky note. Actually, you know what? Let's put this to the side and
Yeah.
we're gonna pull out our notebooks and take some notes, and I am going to include that maximum minimum so that you have a note page on it. So let's get out our notebooks, and I'm gonna pause this while I get mine and get my title made. All right, I've got my page titled. It is day 12, so these will be our day 12 notes. And over to the side, I'll write the date again. It is Thursday, October 23rd. Halloween is a week away. I don't know what I'm gonna dress up as. Gotta get a costume.
Have you ever seen Over the Garden Wall?
Yes.
You can be like a little frog
Oh my gosh.
and make like a little teapot thingy for your head or something.
That would be so
One of those cute little characters.
Love it. No, I need to think of some creative ideas. Okay, so in our notes today, we are going to be talking about max / min parabolas. Because that's how you've seen it written, is max/min. But I'm going to give you the real words. Because there's actually two different versions of max and min. The first word under here will be domain. DOMAIN. And the second word will be range. RANGE. If you have had Algebra 1 before, these words won't be new to you. These will be very familiar. If not, this might be the first time you've ever heard these words, and that is completely okay. As I'm letting you guys get this written down, do any of you know of or have an idea of what domain and range might mean? Any idea?
Isn't it
X and Y.
now? Isn't like one of them like less on the line? Is that
Less on the
range?
line? Kind of. They talk about two different things or two different directions.
Domain will be up or down, and your range will be left to right.
Opposite.
Okay, yeah.
Yes.
It
Yes.
sounded
So
familiar.
actually, you guys are really getting close to the idea. Domain is the span of the x values from left to right. So it's the minimum x value on the graph all the way to the maximum. So domain is the x values. And it's from left to right. So range will be our y values. And that will go up and down. Now, when we're looking at a parabola, put a little sticky note here for a minute. We're going to think about the shape of it. It's always this kind of U shape, pointing either up or down. And we know that these arrows mean that this parabola will extend infinitely up, but also it will extend infinitely to the left and right. Notice how this is not going straight up and down. It's very slightly tilted, which means if I kept going up and up and up and up, like if I were to go up to say 10 million on the y-axis, I go really far up. The left side of that parabola is still going further left the higher up we go, and it keeps going left forever. Same with the right side. It's going to keep going up, but also it's going to keep going to the right and left. So the domain of a parabola is always the same because every parabola extends forever in both directions, left to right. So the domain, if I'm trying to say what is the lowest x value I will reach, there will be no lowest value because it goes to the left forever. So it will be negative infinity is our lowest value. Now, our highest value acts the same way. If there's no highest value, it keeps going to the right forever. What would my highest value be written as?
Positive infinity.
Positive infinity. For a parabola, your domain is always parenthesis negative infinity, comma, positive infinity, parenthesis. So on your quiz, whenever we have this as a bonus question, this will always be the answer for domain. It's like a free point, you guys. Always negative infinity to positive infinity. So we might even want to make a little note. This is always the domain. Now the range will be different every time. And we'll talk about that next. Because the range is going to depend on the direction. So you have two options with range. Because we're looking at the lowest value on the y-axis, so how far down does the graph go, all the way up to how far up does the graph go, we're going to start by giving ourselves two options. I'm going to say, first we have a bracket, and then we have a number, comma, and then we have infinity, parenthesis. And I'm going to show you what this means. Right now, this might look like gibberish. Know that this is the minimum. Minimum comes first. Then is the max. The maximum is infinity whenever the parabola goes up. When the direction is up, the max is infinity. So I'm going to draw it going up. Now here's a trick. Your minimum number will always be the y value of your vertex. How we get that. And I'll show you some examples of this in a moment. So this is our first option for the range. If it faces up, then we'll have bracket number to infinity, parenthesis. Now, if the parabola faces down, then our lowest value, our minimum value, is negative infinity. Our highest value will be a number with a bracket. The number gets the bracket. Parabola facing down for this one. And what's nice about this is it's the same rule here. The y value of your vertex will be the max number. So I'll write that as a little note as well.
What sound is missing with my ADHD?
Now, what is that? Is it music? Okay.
It sounds intense a little bit.
It's just my ADD is like, I cannot fathom.
All right, so let me also circle this y and just point to the fact that this will be the same as this number. And then I'm going to show you examples. So your domain is always negative infinity to positive infinity. And your range is always the minimum or the lowest value up to the highest value. Sometimes that minimum value is a number. Sometimes the maximum value is a number, depending on if it's facing up or down. Okay. Now, before I move this, I do want to make sure that if you are taking notes on this, that you've had time to copy it down. Does anybody need more time to copy this before? Okay, perfect. I will pause and give you guys that time. So I'll leave that where everybody can still see it, but on that worksheet from the do now, let's look at number 1. Here is my parabola. And let's just practice. What is the domain of this parabola? What's my lowest x value? Is there a minimum x value? Does this ever stop going to the left? No. So if there's not a stopping point on the x-axis, what does that mean our lowest value is? Negative infinity.
Okay.
Domain, always this. So negative infinity with parentheses. Now, how far to the right does this extend? Infinity. The domain is always negative infinity, positive infinity, every single time.
You're talking about the arrows.
Yes, the arrows on the end of our parabola tell us that this extends forever. Even if you can't see it go on forever, we assume and we know that it does. It will keep going forever. So that's our domain.
Will be the same for the next one.
Yeah, so for number 2, what's our domain?
Infinity.
Negative infinity, comma, positive infinity.
Again.
There you go, in parentheses.
So for every answer, it would be the negative.
Yep, for your domain anyway, not your range, but your domain is always this, every single time. What about number 3? What is my domain?
Positive. Well, negative.
Negative, positive, yes, it
Negative.
will always be the same. It goes on forever to the left and to the right. So domain for 3 is negative infinity, positive infinity.
Definitely.
What about number 4? What's our domain? Yes. Negative infinity, positive infinity. Good.
My infinity sounds like funny.
That's all right. That's all right.
I'm doing that.
As long as I can kind of tell what it is, then you'll be fine.
Do we need to have to start doing it too, right? The domain and the range.
Only if I ask you for it, and I will only ask for it once on the back of your next quiz, and it will be a bonus question. Normally, we don't practice this at all, but since you guys are showing some interest, we'll go over it. Okay.
Say the first 2.
First 2, the domain is negative infinity, positive infinity. All of them, that's the domain. Every single parabola. So now what we're going to practice is the range, and that part can be a little bit trickier. So before I zoom in on one of these graphs, can I move this now, or does anyone still, are you still writing it? Okay, perfect. So
Guys, making sure the right, are they all negative and positive?
yes, every single one.
I got caught up in writing domain next to it, so I didn't get it confused with.
Oh, right.
Discriminant.
That's smart.
That's what it
Okay, so now let's look at, yes, Gabe?
Oh, for the bottom of the notes, you know, so that for the range, right? That's,
Right here?
yeah, that for the range.
Yes, this is all range. Here, I'll section it off. I don't want that to be confusing. Range is all of this. It's a little more complicated than domain. Domain is always just negative infinity, positive infinity. range, there's a little more to it. So that's why I have all of that. I appreciate you having me clarify. It's right here. Okay, so let's look back at number 1 again, and this time we're going to think about the range. So, my range is how far down on the y-axis does this graph go, and how far up does it go. So we start from the lowest point, and then we go to the highest. So looking at my parabola here, and thinking about the y-axis, where is the lowest point on the y-axis?
It's
Saying infinity, right?
Well, let's see. First, let's ask ourselves, does this point up or down?
Goes up.
It goes up. So I know I'm going to have a number first. So let's see. 6 would be right here.
Oh, okay.
Does the graph go lower than 6?
Are you going
It
down?
does.
Down?
Let's find the lowest point. Where is the actual lowest point? Yes, the lowest point is the vertex. This is where the graph doesn't go any lower than this. So this is my lowest point. My lowest y value is -1. It's the same as the vertex.
It would just be a -1 and then infinity.
Yes, so the range, remember the number gets the bracket. So we'll put a bracket, and the minimum value is -1. And then what's the highest value? What's the very highest it goes? Infinity. We will always have a minimum and the max will be infinity. Or if the minimum is -infinity, the max will be a number.
So we're looking at the arrow for the up.
Yes, yes, yes.
So that's infinity.
That's infinity.
So the down will be the number, and the up will be infinity. Oh,
For
okay.
this one, yes. Yes.
So okay, so number 2 will be high.
You can tell she's really thinking.
Yes,
I
I love it. I love it. Were you going to ask something, Charles?
Basically what she just said.
Okay.
Oh,
Good.
interesting.
Yeah, and if you have this in your notes, this will really, really help because we can look, okay, is it up or down? Well, it's up. Number 1 was facing up. So I know I will have a number as my minimum.
On day 12, like paper-wise.
So -1.
Rewrite it, yeah.
Okay, so how about we look at number 2?
Wouldn't that be negative, what, 2 in infinity?
So first, let's see, this is facing down, right? So we're looking at this range.
Okay.
What is my lowest value? Or is there a lowest value on number 2?
Negative.
Go ahead.
It should be a negative infinity.
Yes, this one is going down. So there is no lowest value. It goes down and extends to -infinity. It never has its lowest point. That's why when we're facing down, the starting point is -infinity.
Because it's going outside.
Yes. So my range right here will start with -infinity. And now we need to see what's our maximum point. What's the highest it goes on the y-axis? Where is my highest point?
Negative, 1.
Yes, it's the y value of the vertex, -1. That's the highest our graph goes. It doesn't go any higher than
Wait,
that.
I blocked it out. Why is the infinity sign first?
The -infinity goes first for the range because we want to think what is the lowest to the highest.
Okay,
So the
we'll always
lowest-
see number and then because minimum, maximum
Yes.
on the notes.
Yes,
if I
yes.
looked, okay.
And there is no lowest when it points down.
You know what? You have to look at the ups and the downs.
Yes, you do.
So we're looking at the orange marks.
Uh-huh.
These.
Yes.
We're looking at these.
We are.
Okay.
We
gotcha.
sure are. And so our max, like we said, was -1
Now get the bracket.
with the bracket.
Yeah.
Good.
Yeah.
Good. All right. All right. All right.
What you,
Alright,
my bad, what did you just say about the range when she asked the question?
Okay, so what did we just say about the range? She was, so Diane was pointing out, oh, we're looking at these orange markings to help us decide, do I write a number first or do I write negative infinity first? If our parabola is facing up, we know the minimum will be a number. There's going to be a point that is our lowest point. But if our parabola is facing down, our minimum is negative infinity because these lines go down for just keeps getting lower and lower. We're learning stuff, guys.
Yeah.
Thank you.
Yes. Okay, let's do 3 and 4 for funsies. See if we got it.
I love using my brain.
Yes.
Yeah.
Okay, so number 3,
Is infinity.
we're gonna find our range. First of all, we're gonna start from the lowest y value. It's facing down, so what's our lowest value?
Negative infinity.
Yes, negative infinity.
So now let's go for the max.
And our highest y value?
Is negative, well, +1.
So here's +1. That would mean it goes up here. Does our parabola reach that?
No.
No.
The bottom, negative right here.
-1.
-1 right there.
Yes, so -1.
With a red dot.
Yes, perfect. Perfect. And -1 is a number, so it gets a bracket. Good.
Bracket.
Okay.
So, sorry.
No, don't be sorry.
I got confused because on the previous range one, we started with the bracket on the left side,
Yes.
parenthesis on the right.
So the reason we started with a bracket for number 1 is because our parabola was facing up. And when it's facing up, bracket and number come first. When it's down, the bracket and number go last.
Gotcha.
Yes.
And
good.
you know what? This
Write
gives
them
us
down.
our answer.
Yes.
Actually,
Yeah,
gives
that
us our
vertex
answers.
gives you the answer.
Yeah.
Yes. Yes. Okay, let's look at number 4. Last one. My range. What is my lowest y value, or is there one? Negative infinity.
Yes.
Good. And my max, my highest y value.
Hello.
It's 4. Yes. It's 4. It matches the vertex's y value. See that?
Our answer over here.
Yes. That is so good, you guys.
So, if you can't find the range, if you can't find the range, it always match the,
The vertex.
vertex.
Yes, yes. So I can add another little note on this page. I wrote, like I pointed to XY, but I think it's easier to tell if I actually write that this is the vertex. The Y value from the vertex is your minimum. Or if it's facing down, the Y of your vertex is your maximum.
Thank you for that.
Absolutely.
Figured it out this out first.
Absolutely.
Then, quick question.
I used to
Yes.
do
On the one we just did for the range, we didn't use any brackets at all.
We did use brackets for the 4.
Oh, I was looking at my bad.
Were you looking at the domain?
Vertex part.
Oh,
Let's
yes,
set the
yes.
data 5 before.
Gotcha. Okay. Good job, guys. I love it. Okay. I know we are pretty far past the time I would normally give you a break. Are we needing a little break right now?
Yes.
Okay, let's take a break. It is 10:40 about. So I would love if we could come back around 10:55. That gives you almost 20 minutes. I'm giving you like 2 extra minutes here. You guys are welcome to go ahead to break. when you come back, we're going to take one more note for this unit, and then I'm going to let you go. Okay, one more little note. So I will pause this, and I'll see you guys back at 10:55. Okay, so we're back from our break, and we're going to take the last little section of notes here on the bottom half of this page. So I told you earlier today, don't know if I put it on the video or not, but I did tell you earlier we would learn about real solutions. Okay, so we're going to make a note below this that says using the discriminant to determine how many real solutions. Using the discriminant to determine how many real solutions. And there are 3 options. The first would be that there are 2 real solutions. Hello, we just started this, so you're not too far behind.
I was walking across the street and this lady, like, crosswalk was my turn to go and she almost hit me and now I'm thinking I should have just jumped in front of the car.
Oh,
I could have got some money.
No. Okay, so your first option is there may be 2 real solutions. And I'm going to leave a little space. The next option is that there could be 1 real solution. And then finally, there is a third option where there could be no real solutions. So, whenever there are 2 real solutions of a quadratic equation, that means whenever you solve for x, you will get 2 numbers for your x values. This is the most common answer, 2 real solutions. So this is referring to your x-intercepts, your zeros, or when you're solving for x. So this means 2 x values you will get 2 real solutions when your discriminant is a positive number or when it's greater than 0. So below that, we're going to write capital D for discriminant is greater than, so we're going to put that greater than symbol. D is greater than 0, which means discriminant is positive. So when your discriminant is a positive number, you have 2 real solutions. Whenever we find the discriminant of a quadratic equation and that discriminant is equal to 0, Like we had some yesterday where our discriminant was 0. When that happens, you get one real solution. We saw that yesterday. When our discriminant equals 0, you only have one real solution, one x value. So to the side of this, we'll write 1 x value. E equals 0. This means discriminant is 0. That's the number you get for the discriminant. And we'll do some examples of these as well. So discriminant is exactly 0. And finally, the third option is no real solutions. This is when you would get no x values. It would be like one of those parabolas where we don't have x-intercepts. There's no x-intercepts, no x values, no solutions that are real. So we put no x values. This happens when our discriminant is a negative number or when discriminant is less than 0. So discriminant less than 0 or discriminant is negative. These. Oh, yes, they're right up there. Let's throw it in there. Yeah, thank you. We'll make sure everybody has a chance to get that written down before we start going through examples. And I'll just pause the recording while you guys do that. So now that we've gotten this written down, we're gonna look at this worksheet I gave you. And we're gonna figure out what does that mean that we just wrote down. So for number 1 on this worksheet, I have given you a quadratic equation, 7x squared plus 5x minus 5 equals 0. We're using the worksheet from right up there. We just started number 1. And the first thing we want to do is find the discriminant. After that, we want to see how many real solutions are there. So when we're finding the discriminant, first, we want to identify A, B, and C. So what are my values for A, B, and C here?
7, 5, 5.
7, 5, and 5. We gotta watch for that sign. -5 is C. Okay, so we have our A, B, and C. And we're just finding the discriminant. So I'm going to write that formula for you, in case we forgot. Discriminant equals, we're plugging in B squared minus 4, plugging in A, plugging in C. With this formula, tell me, where do we go from here?
Put it in.
Plug in our values, absolutely. So what goes into the first blank? 5, that's B. So we have 5 squared. Then what?
-4
Minus 4.
times 7
Good. Instead of A, we'll put 7.
times -5.
Good. Times C, which is -5. Okay. So now we have 5 squared minus 4 times 7 times -5. So what do I do next?
2 times 5.
Not 2 times 5.
5 times 5.
5 times 5. Remember, squaring it is timesing or multiplying it by itself. So 5 times 5.
25.
25. Bring down my -4 times 7 times -5. Now what?
Would that be
-4 by 7 and -5.
Yes.
All that.
Now we want to multiply -4 times 7 times -5,
Which is 100.
which is 100. That's nice. Okay. -4 times 7 times
Oh, no, I did it wrong. I
-5.
actually put 5
Oh,
both times.
is 140. Let's see. Yeah, I got 140. Okay. So I got positive 140.
Yes.
What did you type in? Is it?
No, I actually put all 5s.
Oh.
Definitely.
Oh.
I was like, where did I?
That would be different. Okay. Okay, so we have 140 and it's positive. So when I write my 140 below and my 25, am I writing minus or plus? Plus. Now, remember, if you get a positive number when you multiply, it's plus. We only bring down that minus if we get a negative number when we multiply. So, now I have 25 plus 140, 165. So the discriminant equals 165. Done. We got the discriminant. So
For all the hoopla.
now,
Okay.
So now we got to ask ourselves, how many real solutions? We can look at our note page that we just took, and let's do that. It says if the discriminant is greater than 0 or it's positive, there's 2 real solutions. If it's 0, there's 1. If it's negative or less than 0, there's no solutions. So if the discriminant is 165, is that greater than 0, equal to 0, or less than 0?
Yeah.
Greater. It's greater than 0. So how many real solutions are there? 2. So the way we can write that, because real solutions is a long thing to write out, you can just write 2RS. 2 real solutions. Just to the side as a note, I'll say because D is greater than 0. It's positive. We'll work out one more together, and then I want to give you guys a few minutes to practice this on your own. See if we're getting it, and then I'll review that. Okay, so before we do the next one, do we have any questions about this first problem we've
So
done?
we're not going to do line or X and stuff.
Nope, we're just going to do discriminant for this worksheet just to make sure we understand the real solutions. You are more than welcome to go further and find all the X values, but we'll do a lot more practice with that next week too. Okay, can we look at number 2? All right, so number 2, x squared minus 3x minus 6 equals 0. What's the first thing I should do?
Figure out
Figure out your A, B, and C. A, B, C. So what would my A be?
X squared.
So we're using the x squared term to decide what A is. Remember, A is the number, hang on, let me get that to not be blurry. A, B, and C will never have other letters in there or other variables, just numbers. So if there's no number in front of x squared, what would that number be?
1.
1. There's that invisible 1. So A is 1. You were right on that. How about B?
-3.
-3. And C?
-6.
-6. Good. Good. So 1, -3, and -6. And we want to find the discriminant. So when you think you know it, tell me what I should do next.
Write out your equation of 1x squared. Well, d equals 1x squared minus.
Now let me stop you really quick. You said 1x squared. Where are you putting the 1x in for B? Or
Oh, okay. My bad.
you're okay.
I see what I did wrong.
Okay.
Be -3
Mhm.
x.
Now do I need x?
No.
No, just the numbers at this step. We have b squared. B is -3. So we're going to write -3 for b squared. What's the next part of my formula?
-6 equals 0.
Now wait. What's our discriminant formula? Do you have that written down? We have, I'm going to write it above this just to make sure we have it. It's D discriminant equals B squared. And then there's always right after that -4 times A times C. So we just plugged in our B. It was -3. So, Charles, I'm going to ask you this. We just did B right here. What comes next in the formula?
The -4
Yes, -4. That will always be next. And then what?
times it by the 1.
Good.
Times it again by -6.
Yes. Okay, you got it now. Good. So we're doing B squared, -3 squared, -4 times A is 1 times C is -6. I'll try to keep using different colors. I think that helps to see what we're plugging in. Okay. Plug things in. Where do I go next?
Do the math.
Do the math. What part do I do? What's happening?
Negative.
Yes. -3 times -3 is.
-6.
9.
Check it.
Oh, wait. Go back there.
It's
-3 times 2
times -3.
times,
Not times 2. We're taking it times itself.
-3 times -3 behind.
Yes.
Oh,
-3
-3.
times
If
-3.
you
oh, that's right, negative.
If you click on -3, and then that's the square root of it.
Oh,
So it'll make it so much easier. So you can just hit that and then hit enter.
Are you getting a negative when you do that though?
This.
Yeah.
Okay, I want to teach you guys something really quick on your calculators. If you're having a hard time doing squares like this on your calculator,
Thank you.
so something you can do on your calculator if you don't want to type, like let's say my B was 12. If I have 12 squared, I could do 12 times 12 and get 144, or I could use the squared button. I could type 12 and then click X squared. And now I hit enter and it squares it for me. The reason I didn't use this original, that -3 to show you is because if we have a negative number that we're squaring, we have to do something different. If I type in -3 squared, my calculator is going to follow the order of operations and it's going to say 3 squared is 9, and then I'm going to put that negative on it, which makes no sense. It's going to give you, oops, I didn't need a plus. So -3 squared, it's going to tell you it's -9, and that's wrong.
Okay.
If you want to do that in your calculator, you either need to put parentheses first, which parentheses are right above 8 and 9. I can start, close parenthesis, now type -3,
Parentheses.
another
-3,
parenthesis,
Parentheses.
then hit X squared.
Remember
Okay.
Now it knows that you're saying,
Oh, so-
I want to actually square all of -3, not just +3 and then put a negative on it.
I'm over here showing Diane
Enter.
the wrong way to do it.
Now you got it.
My bad, Pookie.
Okay, thank you. Positive 9.
Yeah.
So you
Yeah.
put the parentheses in there.
Parentheses, they matter.
Look, I'm glad that I brought that
I'm
up, kind
too.
of, sort of.
Mine too.
Oh.
Okay, so we have 9.
Gotcha.
Now what?
You take -4 times 1 times -6.
Perfect.
Let's go.
-4 times 1 times -6.
-6. Yeah, 24.
24.
Positive
So
24.
plus 24 or minus 24?
Plus.
Yes. I love it. Plus 24. Okay. Yeah, let's do the math. What's this?
9 plus 24 equals 33.
Good. Good. Discriminant equals 33.
Okay, let it die. What we want.
How many real solutions?
2.
2. Discriminant is positive. It's bigger than 0. So there's 2 real solutions.
Okay,
Now,
I have a question.
yes.
How did you come up with the RS, the 2 RS?
2RS. Good question. So how did we come up with 2RS? So, bless you. We're looking at our discriminant. I know that it's 33.
Right.
And then I'm looking at my notes I just took. So I'm asking, 33, is this greater than 0? Is it positive? If it is, then I get 2RS, 2 real solutions.
Okay.
If I were to get 0, D equals 0 for my discriminant, I would write 1RS, 1 real solution. If I were to get a negative number for my discriminant, or D is less than 0, I would write no real solutions in RS. Or you could also do that 0 with a cross through it. Okay. So that's what we're using to help us with these problems. I'm going to set a timer for just about, gosh, guys, it is 11:20. We don't have a ton of time left. I'm going to set a timer for, honestly, let's say 10 minutes. And I would love for you all to do a little bit of practice with this. If you feel good about this, if you're like, okay, I got it, this is easy, this is all we're doing today. I just want to make sure that we understand, we feel good. If you feel good, you are welcome to go. You are dismissed. However, I will set a timer for 10 minutes. If you want to make sure that you got it and you want to stick around to do the practice and see, I would love that as well. But I trust that you guys know yourselves and you know if you need the practice or not. This isn't one of those secret tests where if you leave, I'm going to think badly of you.
Thank you.
I will not. I
Well, like
promise.
I said,
So, if you feel good about this, you are free to go. If you want to stay for some practice, I'll set a 10-minute timer to try some on your own. But we'll review this next week too. So, again, not judging you if you go. But I'm going to pause our recording, set a timer. You can stay and practice or you're free to go. Okay, so we have had some time to try some on our own. And let's see. Here's what I'll do. I'm going to go through each of them and tell you what the answers would be. And then you tell me I got them right or I didn't get that one right. Let me figure out what happened. So for number 3, and I'm not going to say the discriminant, I'm just going to tell you how many real solutions, because I don't have the discriminant written out yet, but I can always double check with you if you're unsure. For number 3, you should have gotten no real solutions because your discriminant is a negative number. So we can write no real solutions. You could write NRS. You could write that 0RS. Any of these would work as an answer for number 3, no real solutions. Number 4, you should have 2 real solutions. Number 5, you should have no real solutions. And number 6, 2 real solutions again. Okay. Did anyone get farther than number 6 and want answers for the back side?
I'd be like, dang, Speedy. That's all I could get done.
All right, Brandon, Gabe, did either of you want to see any of them from the back side?
Oh, yeah, so write the answers down and
Okay.
check my work. to see if
Perfect. So I'll go to the back and give you guys those. Number 7, you should get 2 real solutions. Number 8, you should get 2 real solutions again. 2RS, 2RS. Number 9, no real solutions. Number 10, no real solutions again. Number 11, no real solutions. Number 12, 2 real solutions. Number 13, you should get 2 real solutions. And last but not least, for the first or second page here, number 14, 2 real solutions.
So you didn't have any one solutions at all?
No. 1 real solution is the least common that you will have, just because
And then what was 5 to
getting
6
0
again?
is a lot more rare for your discriminant. And then what would you say, Brandon?
What was 5 and 6 again?
5 and 6. I'll go back. No real solutions for 5. 2 real solutions for 6. All right. Do you need to see back again?
I know, I was just confused on, the, like, say like 3x squared minus 108 because there's no b. But I just, so I was wondering if
Yeah, let's look at number 4. 3x squared minus 108. We notice something is missing. Our middle term. We have a number next to x squared. There's no number next to x. There's no x at all. And then we have minus 108. So that would mean when we're identifying A, B, and C, first, what would our A be? 3. If there's no middle term, no x, What does that make B? It's the only number that could make X disappear. 0. So B is 0 in this case. If there's no middle term, no X, it's 0. And then C would be -108. So we can work this one out just because sometimes when you get a B that is 0, it can feel a little uncomfortable, a little awkward to do. So we would follow the same steps. B equals B squared minus 4AC. And let's plug those numbers in. So what goes first?
0.
0. It'd be 0 squared. Minus 4 times what? 3 times,
Negative.
good, -108. And then what would happen here with 0 squared just goes away. 0 times 0 is 0. It's gone.
Bye-bye.
Now all that's left is -4 times 3 times -108. And this is the mistake I saw in a couple people's papers. Is this going to be positive or negative?
Positive.
Positive. You can tell without even doing the math because we have 2 negatives. They
No
will
matter what.
cancel.
2 negatives, no matter what.
Yes, 2 negatives make a positive. So we will get -4 times 3 times -108, 1296, and it's positive. So 2 real solutions. Almost perfect. Okay, are there any other problems that we may want to see? Okay, guys, that's it then. Woo! Next week we will have our Unit 2 quiz. And then we're halfway done with Algebra 2, you guys. At the end of next week, you will officially earn a credit for this class. So that's kind of nice, kind of cool. I don't know exactly the number of credits. I want to say, I think this class is worth 2, either 2 or 4. I don't remember.
That's a big leap.
I know. I don't want to get anybody excited. Ask your life coach. They know those things. I don't. But at the end of next week, you're going to earn at least 1 credit as long as you pass, which every person in this room currently is doing great. So
I feel
no
like
worries.
it's very hard to not pass these classes because you guys help us out so much.
Well, just depends, I guess, on what you're going through and the effort you put in. All right, so we're going to end the recording there. And I hope you guys have a great weekend.
You too.